everyone, and welcome once again to the new session of Revit 2023. And in this session we are going to discuss about the new tool which has been introduced in Revit 2023, and it is called Analytical Automation. The Analytical Automation tool has changed the way we used to create the analytical model in the previous versions. With the introduction of this tool, now the physical and the analytical model creations are explicit. It means that the analytical model creation is a different process as compared to the physical model. So the Analytical Automation tool allows you to create the analytical model from an existing physical model with some specified setting. It uses the Dynamo plugin to create the automation for the physical model in the Revit structure. Now, before seeing how the analytical automation works in Revit and how you can create the analytical model from the Revit physical model, let us understand certain things and see what we are going to learn in this session. Now, in this session, we are going to learn what is a physical model, what is the importance of a physical model, and also we are going to learn about what is an analytical model and what is the difference between an analytical model and physical model in a Revit structure project. Further, you're going to learn about how to convert an existing physical model to an analytical model through the automation tool, or you can also create the analytical model manually. Now, Revit has allowed you to create manual analytical members in the project. Now, you'll also learn further how we can do that. Also, you're going to learn about how to add these analytical model in the project with certain tools which has been introduced in Revit 2023. And in conclusion, at the last, we are going to study about what are the properties of analytical model and how we can modify these properties. Now let's have a brief discussion about, before we go to Revit, let's have a brief discussion about what is a physical model. So when you create any model in Revit structures, a structural model specifically, like a beam or a column or a slab or a wall, which you can schedule, which you can create a section, you can create a detail, you can create a construction documentation out of it. That is the physical model. So the physical model is the representation of the building required for the design and visualization for that structure. So there is an analytical model also that is required for analysis and design. And so analytical model is a representation of the building required for structural analysis and design. So the analytical model can be visualized as a single line, having some analytical properties like force conditions, like support conditions, like end conditions, and there are other things that is added into the properties of the analytical model, which we will study further in this session. Now, in this graphics, you can see how the physical model looks. Here you can see that there is a physical model along with some, the beams and columns, which you can see here, which is a physical model representation. And here you can see that there is an analytical model representation. So here in the analytical model, you have a node, you have a member, and there would be some boundary conditions later on that you can add. So now in Revit 2023, you can basically convert this physical model with the Analytical Automation tool to the analytical model. So in the previous versions of Revit, the analytical model used to coexist within the physical model, but now it is an explicit task. So we'll learn about how the automation tool works further. So the Revit doesn't automatically create the analytical model. So in the previous versions, as we have worked upon, we have seen that the analytical model used to be created within the physical model. But now in Revit 2023, the analytical model is not created automatically, but you can automate the creation of the analytical model or add the analytical model manually in the project. Now, how do you do that? How the automation works? So the automation works is by a analysis engine or the automation engine provided by Dynamo, and this is what it looks like. So this is a window, and here we have some inputs, we have the adjustments, the tolerances, there are settings over there. You need to select the physical element, and then you have to run the engine. So with this, the physical model that is there in your project converts the physical members into an analytical member. So you can create an analytical model based on physical model in Revit. And it also allows you to create an analytical model without having the physical model. So if you don't have a physical model, you can also create an analytical model. And if you require it to get it analyzed in softwares like eTabs or in softwares like SAFE or any other robust structural analysis, good example. The analytical member properties now only show parameters related to analytical purpose. Now you can see that how the properties looks like. So these are the properties that are there in the analytical members. Now we'll move to Revit and see that how the automation works, how you can create the analytical model, and then also we'll learn a bit about how you can add some member supports and boundary conditions. Now let's go to Revit. We are now into the Revit 2023 interface, and now you can see here that there is a physical model created for a project. So in the physical model we have some columns which are basically the steel members, the universal beam column members, and then we have a slab over here, and then we have some structural beams here. Now the physical model, as we discussed, the physical model is the physical representation of the structure. So it has the quantities, it has the sections. Now you can see that it has a quantity, it has a section, and it has sizes, and it can be scheduled, right? So here for the columns, for the beams, the physical representation of the model is as the building structure looks like. But the analytical model is a different modeling part which is created from the physical model for the analysis and design. That means it is used for the analysis and design in softwares like robust structural analysis, SAFE, or eTab. Now in Revit 2023, as you can see here in the interface, we have got this Analyze tab over here in the ribbon, and in the Analyze tab in the ribbon you can see that there is one panel which is named as Structural Analytical Model. So this particular panel consists of several tools which is used for defining the structural analytical member or defining the panels, to create the links, to add boundary conditions, to add loads and other load cases and combinations. But here we have this tool in this panel called as Analytical Automation tool. Now once you click this tool, once you have, so when you decide to create an analytical model, at what stage of the project you want to basically create the analytical model. So let's have a brief understanding about it. So once you are finished with the creation of the columns, beams, and you are okay with the structures, that means now you want to look how the the model looks like in analytical part, and you want to basically now take this model, the analytical counterpart, to the softwares like Revit, Robo Structural Analysis, or eTab. Now at that moment of time you're going to create the analytical model. In the previous versions of Revit, the analytical model used to coexist with the physical model, but now that workflow has changed. Now either you can create the analytical members manually, or you can use the automation tool to create the analytical model out of the physical model. Now once we are sure that the physical model is as we required for the analysis, we choose the Analytical Automation tool from the Structural Analytical Model panel. Now when we choose it, it will take a bit of time to open the structural analytical automation window. Now let's wait to open the analytical automation window. And then we will understand how the analytical automation window can be used to create the analytical model. Now you can see that the analytical automation window here. Now there is a choose folder option. So choose folder option is the folder from where the analytical samples are taken for the Dynamo program to automate the physical model. And then here we have this physical to analytical for buildings tool over there. You just need to click here to start the process. Now it will also take time to settle down with the different options. Now here we are. Now this particular window now populates with different specifications. The first thing that you can see here is the description over here. So it says that it generates the structural analytical model based on selected physical element. Once the model built, it can be updated based on the physical model changes. That means if you have a change in the cross section, if you change in the geometry, the analytical model will also be updated as per the change. Now there is a URL over here where the you can find out more information about this analytical for building tool. I mean the options in this particular window. Now coming back over here, in the inputs area, you can see you have to select the physical element that you want to select for automation. So I select the physical, I choose the select tool, and it says that select in Revit. So I'm going to create a window over here. Now you can see here I selected the elements. Now I have a filter option here. So the moment I select it, there is a contextual tab as modify multi-select contextual tab is displayed. So you need to choose the filter tool from the selection panel. And I'm going to filter out all other things, except I'm going to keep the columns, the framings and the floors, and apply. Right. So now you can see the total elements which is selected is 20. You can see the element IDs over here of the selected elements. Now here there are certain settings like the adjustment of the analytical elements using connectivity rules. So I put it true. Tolerance of the distance between analytical elements, value in the project length unit. So if you put some tolerances, like for example, if there is some gaps, you want to fill it, and you want the automation tool to create the analytical model, so you can keep a tolerance over here. Adjustments, yes. Tolerance of the distance to the nearest level. Again, this is about the distance. This is for the analytical elements. This is for the tolerance of distance between the levels. And then we have the first group of element considered for adjustment. So we don't have a wall, so I can take it as a column. Second group of elements in priority basis with the beam, and the third group of element I'll put it as floor. And other options like inheritance of properties in the analytical element from the physical elements, I say yes. Create analytical opening for selected floors. If there is a opening over here in the floor, it will create an analytical opening, and association with the physical counterpart. So I put all these values, keep the default values, and then at last there is an option I can do a run. The moment I do the run, the engine runs and it basically starts creating the analytical model out of the physical model. So this is the operation which is going back in, and we need to wait till the analytical model is created. Now it's done. Now you can close this, and here we have this in the 3D view. You can click here for the analytical model. You can see the slab, you can see the analytical columns, analytical members. Now in this analytical model 3D view, you can see that there is analytical column, there is an analytical slab, there is an analytical beam. Now it has been created as per the specification that has been given in the Analytical Automation window. Now if you want to see the properties of these analytical elements, so you can click here or to any element, analytical element, so you can see the properties. Here we have a constraints. This is based on the physical model. You have the structural material, you have the structural role, you have the section type, and then how you want to analyze, and there are different conditions that you want to give, the end member conditions for the members, and then the member forces that you want to add. So there are various options that is there in the properties that you can work to modify the analytical properties of the analytical members. So now we have learned about what is a 3D model and what is the analytical model. Now here in the 3D model, you can see that there is an analytical model that exists over here. So here in the view control tab, there is an option which says that hide analytical model and show analytical model. So by which you can now basically toggle between the display of analytical model and physical model. So there are other tools. So let's go to the analytical model view and let's have a brief discussion about what we can do more with the other tools in the structural analytical model. So we can create a member. Let's say if I want to create a manual member, I want to create a bracing over here. So here I click on the member and then I can add manually. So you can see how manually it can be created. So if I want to create a panel, so I can create a panel by using, let's say, a rectangular tool. So here I can create a panel. So if I require a panel to be created, the panel can be created at this particular point. So, so here the Revit 2023 now allows you with greater options of working with the analytical model, tweaking the analytical model, customizing the analytical model, and gives you a best platform for taking this physical model to softwares like RoboStructural Analysis, ETAP for analysis. And at last, I just wanted to mention about how the load conditions are given. So you have this load tool. So you can see that there are load that you can basically assign, like the point load, the line load, area load, hosted point load, hosted line load. So if you click on any of the tool, you will find that there are different options that you can work. So, so this is how you prepare the model for analysis before you take it to softwares like Robo or ETAP. Thank you for watching this session, and hopefully in the next session we will learn more about how we can take this model to RoboStructural Analysis, and then we will see how the design iteration can be done. Thank you.